Hello everyone, and welcome to this NPTEL course on an introduction to machine learning. In this course, we will have a quick introduction to machine learning, and this will not be very deep in a mathematical sense, but it will have some amount of mathematical rigor. And what we will be doing in this course is covering different paradigms of machine learning, and with special emphasis on classification and regression tasks, and also we will introduce you to various other machine learning paradigms. Right. In this introductory lecture, set of lectures, I will give a very quick overview of the different kinds of machine learning paradigms, and therefore I call this lectures machine learning a brief introduction with emphasis on brief. Right. So, the rest of the course would be a more elongated introduction to machine learning. Right. So, what is machine learning? So, I will start off with a canonical definition put out by Tom Mitchell in 97. So, a machine or an agent, I deliberately leave the beginning undefined, because you could also apply this to non-machines like biological agents. So, an agent is said to learn from experience with respect to some class of tasks, right, under performance measure P, if the learner's performance at tasks in the class as measured by P improves with experience. So, what we get from this? The first thing is, we have to define learning with respect to a specific class of tasks. Right? It could be answering exams in a particular subject, right, or it could be diagnosing patients of a specific illness. Right? So, but we have to be very careful about defining the set of tasks on which we are going to define this learning. Right? And the second thing we need is kind of a performance measure P. Right? So, in the absence of a performance measure P, you would start make vague statement like, oh, I think something is happening, right? There seems to be a change, and something learned, there is some learning going on and stuff like that. So, if you want to be more clear about measuring whether learning is happening or not, you first need to define some kind of a performance criteria. Right? So, for example, if you talk about answering questions in an exam, your performance criterion could very well be the number of marks that you get, or if you talk about diagnosing illness, then your performance measure would be the number of patients that you save, or the number of patients who did not have adverse reaction to the drugs you gave them. There could be a variety of ways of defining performance measures depending on what you are looking for. Right? And the third important component here is experience. Right? So, with experience, the performance has to improve. Right? And so, what we mean by experience here, in the case of writing exams, it could be writing more exams. Right? So, the more the number of exams you write, the better you write it, better you get at test taking, or it could be patients in the case of diagnosing illnesses. Right? The more patients that you look at, the better you become at diagnosing illness. Right? So, these are the three components. So, you need a class of tasks, you need a performance measure, and you need some well defined experience. So, this kind of learning, right, where you are learning to improve your performance based on experience, is known as this kind of learning where you are trying to where you learn to improve your performance with experience is known as inductive learning. Right? And the basis of inductive learning goes back several centuries. People have been debating about inductive learning for hundreds of years now, and it's only more recently we have started to have more quantified mechanisms of learning. Right? So, but one thing I always point out to people is that you should take this definition with a pinch of salt. So, for example, you could think about the task as fitting your foot comfortably. Right? So, you could talk about whether a slipper fits your foot comfortably, or let me So, I always say that you should take this definition with a pinch of salt, because let us take the example of a slipper. So, the slipper is supposed to give protection to your foot, right, and a performance measure for the slipper would be whether it is fitting the leg comfortably or not, or whether it is as people say, whether it is biting your leg or is it chafing your feet, right. And with experience, as the slipper knows more and more about your foot, as you keep wearing the slipper for longer periods of time, it becomes better at the task of fitting your foot, right, as measured by whether it is chafing your foot or whether it is biting your foot or not, right. So, would you say that the slipper is learned to fit your foot? Well, by this definition, yes, right. So, you have to take this with a pinch of salt, and so not every system that conforms to this definition of learning can be said to learn usually. Okay. So, going on, so there are different machine learning paradigms that we will talk about, and the first one is supervised learning, where you learn an input to output map, right. So, you are given some kind of an input, it could be a description of the patient who comes to the clinic, and the output that you have to produce is whether the patient has a certain disease or not, right. So, this you have to learn this kind of an input to output map, or the input could be some kind of a question, right, and then the output would be the answer to the question, or it could be a true or false question. I give you a description of the question, you have to give me true or false as the output. And in supervised learning, what you essentially do is learn a mapping from these inputs to the required output, right. If the output that you are looking for happens to be a categorical output, like whether he has a disease or does not have a disease, or whether the answer is true or false, then the supervised learning problem is called a classification problem, right. And if the output happens to be a continuous value, like so how long will this product last before it fails, right, or what is the expected rainfall tomorrow, right. So, these kinds of problems they would be called as regression problems, right. These are supervised learning problems where the output is a continuous value, and these are called as regression problems, right. So, we will look at in more detail classification and regression as we go on, right. So, the second class of problems are known as unsupervised learning problems, right, where the goal is not really to produce an output in response to an input, but given a set of data, right, we have to discover patterns in the data, right. So, that is more of that is called unsupervised learning. There is no real desired output that we are looking for, right. We are more interested in finding patterns in the data, right. So, clustering, right, is one task, one unsupervised learning task, where you are interested in finding cohesive groups among the input patterns, right. For example, I might be looking at customers who come to my shop, right, and I want to figure out if there are categories of customers, like so maybe college students could be one category, and so young IT professionals could be another category, and so on and so forth. I mean, when I am looking at this kinds of grouping in my data, so I would call that as a clustering task, right. So, the other popular unsupervised learning paradigm is known as association rule mining or frequent pattern mining, where you are interested in finding a frequent co-occurrence of items, right, in the data that is given to you. So, whenever A comes to my shop, B also comes to my shop, right. So, those kinds of co-occurrence. So, I can always say that okay, if I see A, then there is very likely that B is also in my shop somewhere, So, I can learn these kinds of associations between data, right. And again we will look at this later in more detail, and these are, I mean, there are many different variants on supervised and unsupervised learning, but these are the main ones that we will look at. So, the third form of learning, which is called reinforcement learning, it is neither supervised nor unsupervised in nature, and typically these are problems where you are learning to control the behavior of a system, and I will give you more intuition into reinforcement learning in one of the later modules. So, like I said earlier, so for every task, right, so you need to have some kind of a performance measure. So, if you are looking at classification, the performance measure is going to be classification error. So, typically, right, so we will talk about many different performance measures in the duration of this course, but the typical performance measure you would want to use is classification error, right. So, how many of the items or how many of the patients did I get incorrect? So, how many of them who are not having the disease did I predict had the disease, and how many of them that had the disease that I missed, right. So, that would be one of the measures that I would use, and that would be the measure that we want to use, but we will see later that often that is not It is not possible to actually learn directly with respect to this measure. So, we use other forms. Right, and likewise for regression again, so we have the prediction error. Suppose I say it is going to rain like 23 millimeters and then it ends up raining like 49 centimeters, I do not know. So, that is a huge prediction error, right. And in terms of clustering, so this becomes a little trickier to define performance measures. We do not know what is a good clustering algorithm, because we do not know how to measure the quality of clusters. So, people come up with all different kinds of measures, and so one of the more popular ones is a scatter or spread of the cluster, that essentially tells you how spread out the points are that belong to a single group. If you remember, we are supposed to find cohesive groups. So, if the group is not that cohesive, it is not all of them or not together, then you would say the clustering is of a poorer quality. Right. And if you have other ways of measuring things, like I was telling you, so if you know that people are college students, right, and then you can figure out that what fraction of your cluster are college students. So, you can do these kinds of external evaluations. So, one measure that people use popularly there is known as purity, right. And in association rule mining, we use a variety of measures called support and confidence. That takes a little bit of work to explain support and confidence. So, I will defer it until I talk about association rules in detail. And more in the reinforcement learning task. So, if you remember, I told you it is learning to control. So, you are going to have a cost for controlling the system, and so the measure here is cost, and you would like to minimize the cost that you are going to accrue while controlling the system. Okay, so, these are the basic machine learning tasks. So, there are several challenges when you are trying to build a machine learning solution, right. So, a few of these I have listed on this slide, right. The first one is you have to think about how good is a model that you have learned, right. So, I talked about a few measures on the previous slide, but often those are not sufficient. There are other practical considerations that come into play, and we will look at some of these towards the middle of the course somewhere, right. And the bulk of the time would be spent on answering the second question, which is how do I choose a model, right. So, given some kind of data, which will be the experience that we are talking about. So, given this experience, how would I choose a model, right, that somehow learns what I want to do, right. So, how that improves itself with experience and so on and so forth. How do I choose this model, and how do I actually find the parameters of the model that gives me the right answer, right. So, this is what we will spend much of our time on in this course, and then there are a whole bunch of other things that you really have to answer to be able to build useful machine learning, useful data analytics or data mining solutions. Questions like, do I have enough data, do I have enough experience to say that my model is good, right. Is the data, is it of sufficient quality? There could be errors in the data, right. Suppose I have medical data and age is recorded as 225. So, what does that mean? It could be 225 days, in which case it is a reasonable number. It could be 22.5 years, which again is a reasonable number, or 22.5 months is reasonable. But if it is 225 years, it is not a reasonable number. So, there is something wrong in the data, right. So, how do you handle these things, or noise in images, right, or missing values? So, I will talk briefly about handling missing values later in the course, but this is, as I mentioned in the beginning, is a machine learning course, right, and this is not primarily, it's primarily concerned about the algorithms of machine learning and the math and the intuition behind those, and not necessarily about the questions of building a practical systems based on this. So, I will be talking about many of these issues during the course, but just that I want to reiterate that will not be the focus, right. And so, the next the challenge I have listed here is how confident can I be of the results, and about that I certainly will talk a little bit, because the whole premise of reporting machine learning results depends on how confident you can be of the results, right. And the last question, am I describing the data correctly? Okay, so that is a very domain dependent and a question that you can answer only with your experience as a machine learning or a data sciences professional, or with time, right. So, but there are typical questions that you would like to ask that are there on the slides. So, from the next in the next module, we will look at the different learning paradigms in slightly more detail.